Thank you very much for the kind introduction, Professor Kawaguchi. It's a great honor for me to be able to speak here at this conference. I think, especially in these days, it's very important to keep connected, to keep in exchange with the community of engineers. And so this conference is very important, I think, and also my thanks go to Ali Reza and the whole organizing team for setting this up. And yeah, it's a great pleasure for me to be here. I took the motto of the conference somewhat seriously and also quite personally. So you may hopefully forgive me if this presentation is rather a personal account than very scientifically or technically focused presentation. But I really was thinking about what inspiration means and what it could mean in our work and how we communicate it to others. To start off, I want to talk about the maybe underlying theme that everybody nowadays is, of course, thinking about and working on, which is the climate crisis that we're in, and the way that we have to change our ways of working and living in order to save this planet for ourselves and for the generations to come. And the United Nations have put out a list of 17 sustainable development goals, of which at least 2 are directly linked to the construction industry in infrastructure and sustainable cities and communities. Of course, many others are also very relevant to the work that we do. And I think when we talk about inspiring the next generation, we should have these goals in mind because they're basically everybody's job to work on these and to conserve this planet that we're living on. We only have this one. So this is the kind of the underlying theme, I think, that we're all talking about, whatever scientific progress or examples from practice we may be talking about here. When I think back to the moment or the time when I was sort of got interested in a career as a structural design engineer, I can specifically remember a certain day. This was in the early 1990s when I was studying civil engineering at the Berlin Technical University. And we heard yesterday in Ali Reza's initial speech that inspiration, of course, always goes back to persons and their personalities. And in my case, I remember one day I was sitting in class and it was announced that the same evening a certain professor, Jörg Schlaich from Stuttgart, was giving an evening lecture. So I got interested and I went. And I must say, this was kind of an eye-opener for me, and this really got me started in the whole way I see this job that I was getting trained to perform. And from the way that Jörg Schlaich presented his ideas and his projects with a certain logic, with a certain courage that you can feel in his work, and also certain humbleness. This really gave me a whole different perception of what engineering could be, beyond the numbers, beyond the math, beyond the differential equations and stress-strain diagrams. I was particularly impressed by the seemingly playful approach that he was talking about, or that he was displaying in his structural design. When you look at his career, and here we see him in an image from the late 1960s, from the Munich 1972 Olympic complex. You can see that certainly knowledge, a firm academic background, creativity, but also curiosity and courage are the ingredients to make truly amazing projects. And you see him here at the center of a group of people, which were basically the core design team of the 1972 Olympics. So from left to right, quickly, there's Heinz Isler, there's Fritz Auer, the architect, there's Frei Otto, then there's Jörg Schlaich, there's Fritz Leonhardt, in whose offices he was working at the time. There's Rudi Bergermann, with whom he later went to found his own practice, and Knut Gabriel. And if you look at the sheer dimensions and the sheer amount of innovations and unknown solutions at the beginning of this project that was developed and that were novel concepts for structural detailing, novel ways to calculate and design such, tensile structures in these unparalleled dimensions at the time. This is really breathtaking, and I think it's a very good example of, as I said, how courage and creativity can bring about great results. Certainly, Jörg Schlaich also drew his inspiration from other predecessors, other important engineers before him. So there's certainly Vladimir Shukhov can be named with his parabolic radio masts with very minimalistic design and material usage. And these obviously inspired Jörg Schlaich to come up with kind of an inversion of this principle in a tensile structure, which is a cable net tower for either a cooling tower for a power plant or just a viewing tower for recreation. In the field of bridges, he was obviously looking at Robert Maillard's work, the famous Salginat-Hobel bridge. Again, inversion or transformation. If you turn it upside down, it becomes the structure of the new railway bridge in Stuttgart across the Neckar River. There's many more, but maybe one that should be named is, of course, Felix Candela with his amazing concrete shells that he built, mostly in Mexico. And this inspired Jörg Schlaich to come out with this pavilion in Stuttgart for a gardening exhibition with a very similar geometry and structural form, but novel materials in this case with sprayed fiber reinforced concrete. And one other thing that always struck me about him is that his ability to simplify things and to break down things to a simple denominator. And then if you have that ability, then the bicycle wheel becomes the structural principle for a Stuttgart football stadium. Or a tennis racket becomes the cable net glass facade for the Kempinski Hotel at Munich Airport. Or a kitchen sieve becomes the structure of a spherical grid shell dome above a swimming pool in Neckarsulm. So, of course, later then I had the opportunity to join the practice. And even though Jörg Schlaich is now retired from the practical engineering, his ideas and his spirit certainly live on in the office and influence and inform the way we work here every day. And within the management, we have tried to define basically what are the underlying principles that guide us and what are our values. And you see here kind of a circle that includes many aspects, among others, homage, innovation, courage, and naturally also sustainability, which now, of course, is a very widespread term that everybody uses and everybody has taken seriously. It's always been within the context of our work, because, of course, making efficient structures can automatically mean that you're using less resources and you're working towards sustainable results. I want to show a few examples from our recent work, which have already been published, even maybe in this context here at this conference in the previous year. But it's all about telling stories, I think, and I want to show these projects in the context of the question of inspiration and the roots. So you all know the Dorton Arena in Raleigh in North Carolina, a very fine example of a doubly curved cable net with a concrete edge girder that is continuously supported on the facade. And in 2014, we had already built a similar structure in the city of Wolfsburg in Germany with a freestanding cantilevering doubly curved cable net covered with a PTFE membrane for the Volkswagen car factory. And in the following year, we had the opportunity to work on a competition together with architects Graft. And here we also applied a similar principle, but with a bit bigger dimension. So here we were certainly inspired by the predecessors, by the example of the Riley Arena. However, the boundary conditions were a bit different here. So first we sat down and studied how these orthogonal cable nets work when you have different shapes of edge girders to attain a bending moment-free edge girder. And then, of course, when you go into 3 dimensions, how do the push and pull forces work if you have a continuous column around the perimeter. But in this project, it was a bit different. We wanted to have a completely freestanding structure with only 2 supports at the ends and a span of about 80 meters. So we had to go into a bit more studies to get this all working efficiently and effectively with a bending moment-free edge girder. And what we ended up with was the system of a cable net that was pre-stressed against a steel edge girder in a spatially curved form, and then a PTFE membrane that is basically lying on the cable net. And then underground, of course, you have some abutments and some PT links to connect the horizontal thrust under the ground. So then the steel structure came up, and you can see this expressive geometric form, which is, of course, a result of the structural form finding more than architecture. And yeah, and then the other thing, of course, is getting the details right to come out with a really convincing overall results. So a very clean solution also for all the little parts where, for example, all the cables are joining with the edge girder. A nice and clean cable node between the membrane and the cable network, and even down to the welds between the membrane patches, that they would properly align with everything else. And I think it can be said that the result is pleasant and is giving also new life to the existing ice rink that it's covering. During day and during night and all around the year now, this historic ice rink location has been transformed into a venue for all sorts of sports and leisure activities. Another quick example I want to give is about compression shells. And I was quite pleased yesterday when I heard Mareike Mollard's keynote, and she was talking about how sort of physical modeling for form finding is still important today. And this fits very well with my little presentation here of this project of a footbridge in Ditzing in southern Germany, where we started thinking about structural form. And Mike Schlaich was one summer evening sitting on his terrace and playing around with this orange net, you know, this plastic net where you can buy your oranges at the supermarket. And he was sort of, with his means that he had at his home, playing around with the form finding, actually for a very thin compression shell, which ended up a 20 millimeter stainless steel plate, doubly curved, and with some reinforcement around the edges, some stiffness. And the underlying idea was to make the structure of this bridge a true shell with membrane action, but also to visualize the flow of forces and stresses in the shell by basically cutting away the non-used material, so it gets the appearance of this net that we have seen before. Excuse me. And we came out, as I said, with a 20 millimeter thick steel plate. And if you compare this is a small project, it's only 20 meter main span. But if you compare it with something that we think is very efficient, the shell of a chicken's egg, we're actually about 6 times thinner. So if you compare the ratio of wall thickness to length or span between a chicken egg and our footbridge, it's 150 to 1000. So I think this is kind of an example that it actually works very efficiently as a shell. Some impressions from the manufacturing process. One interesting aspect here is that the client is actually a company that makes laser cutting machines for steel plates. And so they very much like the idea of perforating these steel plates because they could do it with their own machines. The elements were then pre-deformed into the doubly curved geometry and then assembled and welded together by some other subcontractors. Everything was pre-assembled in order to assure the fit on site. And then finally brought to site for the final assembly of the whole structure. And what you see in this picture, these chaps here, they had to spend a few days with a very fine work, because in addition to perforating the sides of the shell, we also decided to perforate the walkway. And of course, you have to make sure that people don't get stuck in any openings in the walkway. So we decided to use a large amount of small drillings that would get closed with these glass plugs. And these two poor guys here had the job of gluing in about 17,000 glass plugs into the bridge deck in a matter of a few days. But then it was time to lift the whole structure in place over the road that it was crossing. And then you can see here in the underside, this perforation with the glass plugs really has an effect. So the whole appearance is quite light and quite transparent. And then also different views of the finished bridge. It also received a very high transparent and low reflection glass parapet in order to underline the lightness of the whole design. And even at night, with a lighting concept that we also developed, it's quite an amazing view. The sustainability of a project is not only defined by the minimization of the material usage, it can also be read in the context of what happens in the future with a project that is now designed for a certain purpose, for example, a football stadium. What happens after the event, what happens after the World Cup, for example, in 2022 in Qatar. And here's an example how we, in a design team with architects and other engineers, came up with maybe a novel approach to stadium design. The FIFA projects for the 2022 Qatar Football Cup include this venue at a very prominent location at the waterfront of Doha, and the site is actually very valuable. So after the event, it should be redeveloped into for other purposes. And we came up together with the other design team members with this scheme of saying, okay, what if we can design a stadium that's completely deployable, and then after the event can be taken apart and then be shipped somewhere else and reassembled for another life. And not just that, but we also thought about modularity. So maybe the afterlife will not be as another football stadium, but can we come up with a solution that is so modular that it can actually be converted into some other sports venue, for example, a smaller size stadium, or even using single grandstands for other purposes such as tennis or car races or whatever. So the whole design is completely modular throughout. It's completely deployable. So all the connections are bolted. There's a very high degree of repetition. There's a very strict geometric logic of the form. All the connections, of course, must be very carefully designed to be to be completely dismantleable. All the elements must be broken down into sizes that will later fit into containers, normal seaworthy shipping containers. And you see here, for example, the red parts here in the left side is the part of the roof truss, and all the other elements like columns and even the breakers and the seating tiers are fit into 40-foot containers for shipping. Then there are also special containers for example, ventilation units or toilets or kiosks or media facilities or changing rooms. All these functions are located in containers which can later be just basically pulled out of the structure and relocated. Yeah, and this is the result. I would say, it's a fully functional 40,000-seater stadium with its own special aesthetics. It doesn't have a facade, for example, but it's completely operational. And it's currently under construction, and it will be finished on schedule for the games next year. Another aspect of structural engineering where we can contribute to solving the world's energy problems is solar energy. And I want to just briefly touch on this as I come towards the end of my presentation. The size of land that would be required to cater for the world's energy needs purely from solar energy have been calculated for projected to 2030. And you see this little greenish square at the lower left of the picture. This is about 500,000 square kilometers by current technology, including all the efficiencies that would be required to feed the world with energy just from solar. And in our office, we've had a working group for the last 40 years, which has worked on developing solar thermal collectors, different generations you see here, so-called trough collectors, which focus the sunlight on a line. And then these collectors are arranged in large arrays and then connected to a steam turbine. Another form is a so-called tower type power station, where the sunlight is focused by different small mirrors on a single point at the tip of a tower. And this is basically the principle. So why am I telling you all this? What does this have to do with structural engineering? Well, structural engineers contribute to the development and to the construction and to the quality assurance and to the installation of these devices. And within our office, we have spent a joint effort between structural engineers, between mechanical engineers, between physicists to come out with an optimized design. Here you see this is sort of the conventional design for such a mirror for a heliostat tower type power station, and we have come out with a optimized design, which is more a radial than an orthogonal grid, in order to create more evenly distributed structural usage. So utilization of material. And we have used the very same methods and tools that we use in structural engineering of a bridge or a building. And you see here on the right hand our optimized design versus the conventional on the left. And also the pylon geometry and construction method was optimized. Yeah, and the result is this patented collector, which now, for example, has been installed in China into a 50 megawatts power station. Finally, when we talk about inspiration, just one final note here. It's also maybe interesting to talk about the relationship of engineering and art. Currently, we're working on a project in Paris, the wrapping of the Arc de Triomphe by the late artist Christo, who passed away unfortunately in May this year. But this is an ongoing project which is being finished at the moment. So as I speak, the the installation of the substructure on the Ark is being installed, and the membrane is coming up next. So we spent in the past 2 years a lot of time preparing and engineering this project, and we're happy that it's really taking place now. So any of you who have the chance to travel to Paris between September 18 and October 3rd could enjoy this project, which is up for 2 weeks. Well, that concludes my presentation. I hope I could give you a bit an insight into our work and maybe some aspects about inspiration. And thank you very much for listening.